All right, we're on to lecture 5. So this lecture again, I'm going to break up into 3 parts. This first part, we're going to talk about solids, liquids, and gases. So that's like another way of dividing up matter. We'll talk about that in just a minute. Second 2 videos are going to be a little bit more mathematical. We're going to talk about density, how to calculate density, what is density. And then in the last part of this lecture, we're going to talk about temperature. And again, it'll involve like some calculations there as well. All right, so let's go ahead and move on and let's get into, actually, you know what? Before we get into solids, liquids, and gases, we need to do something we haven't done in a while. Oh my God, we haven't looked at the periodic table. We haven't learned elements in a while. We got to keep learning these elements. So it is time to learn a few more symbols. So far I've covered 1 through 10. Today, we're going to look at the periodic table, and you need to be familiar with, you really need to know off the top of your head, honestly, if you're going to make it through this class, what the symbols are. And today, we're going to do 11 through 20. So 11, when you see Na, what does that stand for? 12, when you see Mg, what does that stand for? 13, when you see Al, what does that stand for? 14. When you see SI, what does that stand for? 15. When you see P, what does that stand for? 16. S, what does that stand for? 17. CL, what is that? Oh, I'll go over here a little bit. 18, what is AR? And our last 2, 19 is K and 20 is, oops, CA. We'll go with CA right there. All right, so some of these are ones that, you've probably heard of because, they're important in your diet and your biology classes. If you've taken one, maybe you've heard of these. Like, for example, Na. Na is the one that, if you get too much of it, it can give you heart disease. It can give you high blood pressure. You don't want a whole lot of Na in you. Na stands for sodium. So, by the way, you want to learn to spell these things too. All right, Mg. Now, Mg is actually another one you need in your diet. You don't need a whole lot of it. You need a little bit of it. You'll find it in a multivitamin. Mg stands for magnesium. We move on to Al. What the heck can I tell you about Al? Oh, Al. They make airplanes out of it. It's a really light metal. You probably have some in your kitchen. You have some foil made out of it. Aluminum. Aluminum foil. All right, aluminum. All right, SI. What can I tell you about SI? SI is used in computers. If you got a cell phone or calculator, there's probably some SI inside of it. It's used, actually, there's an area up by San Francisco named after it because they build a lot of or design a lot of computers up there. SI is silicon. Silicon Valley. Maybe you heard of Silicon Valley. All right, up where Apple and Google and all those companies work. All right, how about P? What can I tell you about P? P, oh, that's one again you need for your body. You get it from like plants and vegetables and stuff. Let's see. It's part of some DNA and stuff like that. So anybody know what P is? P is phosphorus. Phosphorus. And then, how about S? Oh, S, 16S. S, we used in a demo a while ago. It was like a yellowish kind of rocky looking material, kind of soft rock. S stands for sulfur. We get to Cl. Cl is, oh, they use it to clean pools. What do they put in pools to keep them clean so you don't get sick when you go into a pool? Chlorine. How about AR? AR is a gas, not one that you're going to run across too much. AR is a gas that, let's see, oh, I don't know. It's the punchline of a bad chemistry joke. What do chemists do around a cake? They eat it until it's argon. Argon, get it? Argon, yeah, terrible joke. All right, it's argon, A-R-G-O-N, G-O-N, argon. All right, now our last 2 are ones that, again, you find in your diet. K, you need K. You need K. You get it from a banana. If you don't have any K in you, you're not going to feel so good. K stands for potassium. And then that's an O there. Ugh. And then Ca, oh, you get this from milk, cheese, dairy products. You need some Ca as well. That stands for calcium. All right. So those are our symbols for this week. I'm sorry, got a little messy down here at the bottom. Calcium. Maybe I'll rewrite it real quick just so you know. All right, make sure you kind of know how to spell these things. C-A-L-C-I-U-M. That's a little clearer, huh? All right. So with that, we're going to try to do like 10 a week. I've already gotten a little behind on these, but we'll catch up. In the end, we're going to learn about 40 or 50 symbols we'll end up covering. So with that, really the major part of this video is I want to tell you a little bit about the difference between a solid and a liquid and a gas. So let me flip over to one more slide, and we're going to get into that. What's the difference between a solid, a liquid, and a gas? So solids, liquids, and gases are ways of dividing up matter. So we talked about earlier how you can divide up the universe, everything we see, as either an element or a compound or a mixture. Totally true, but there's another way you can divide up everything you see. It can be a solid or a liquid or a gas. So it's just a different way of kind of breaking up things so we can kind of understand them. So these three, solids, liquids, and gases, these are called the I should get a pen here. Switch colors, huh? The three phases of matter. So everything around us, matter, will fit into one of these categories. So what makes something fit into these categories is kind of how they behave when you transfer things from place to place. Some things, when you transfer them from place to place, they keep the same shape. Some things, when you transfer them from place to place, they keep the same volume. They keep the same size. So what's different is whether or not that's true. That's what makes things either solids, liquids, or gases. So let's go through like an example here. So let's say I was to think about a solid. Like a solid might be, I don't know, this pen, or this calculator, I guess, huh? So if you have a calculator and you move it from one place to another, so I have it in my hand right now, and then, I don't know, I stick it in this beaker, does the shape of the calculator change, or does it stays the same? It stays the same, right? The calculator still looks like the same shape. It's still kind of a square rectangle. So yes, it keeps the same shape. Now what about the size of this calculator? If I take it in my hand and I decide to throw it in this beaker, did it get bigger or smaller? No, it keeps the same volume. So that's what makes something a solid. When you move it around, it doesn't change shape, it doesn't change size. It stays the same size and the same shape the whole time. All right, let's move on to a liquid. A liquid, well, you know what probably the commonest liquid is, right? Is water. So if I take water and I have it in this bottle, and I'm now move it into this cup, I'm going to move it into this beaker. So when I move it into here, let's see what's going to happen. So one thing that'll happen is I can pour it. So does it keep the same shape when I move it from one place to another? Well, over here, it's about what? Oh, before we do it, it's maybe what, 5 inches tall or something, 4 inches tall in this bottle. If I move it over here, all of a sudden, instead of being 5 inches tall, it was like up to here, it only goes up an inch or two, you know, because the beaker's wider. So it doesn't keep the same shape. It actually changes shape. If you put it in a tall, skinny container, it's going to be tall and skinny. You pour it into a kind of a rounder, shorter container, it'll be short and round. So liquids do not keep the same shape when you move them around. Do they keep the same shape? No. They don't keep the same shape. You put them in a tall, skinny container, they'll be tall and skinny. If you put them in a wide container, they'll go wide, okay? But what is true for a liquid is when I pour the liquid from one spot to another, it does keep the same volume. If you have 100 milliliters of water and you pour it into a beaker, in the beaker, it's going to still be 100 milliliters of water. So the volume stays the same. So it does not change volume. You have the same volume. Yes, you have the same volume. All right. What about gases? Gases are the last phase. Now for gases, since they're they are actually kind of the hardest one to understand maybe because you don't deal with them so much. I mean, you got, wherever you're sitting right now, there's probably a solid sitting around you, right? You got a solid. Or you probably got a liquid. Maybe you're drinking some water or some coffee right now or whatever, right? Margarita, who knows? So that's a liquid, all right? So you got plenty of examples of those. Gas is not so much. So air is a gas. That's one that's around you. But maybe a better example for what we're talking about right now would be like helium. You run into helium once in a while, like if you have a birthday party or whatever. And in fact, one of my first jobs was to work at a grocery store, and I would fill up balloons when there was a birthday party. You know, people would come in, fill up this balloon, right? And so when I would fill up the balloon, there would be a tank kind of behind the counter of helium, and it was kind of tall and skinny. And then what I would do when they would come in, they would say, "Hey, can you fill up this balloon? Because my kid, my son, my daughter, they love Mickey Mouse, right? So let me draw Mickey Mouse. Is that Mickey Mouse? Sort of. All right, not a very good Mickey Mouse. I'm not an artist. What can I say? All right, so I would go over to the tank and I'd open up the valve and I would take some of the helium out and I would put it in the Mickey Mouse balloon. So when I do that, the gas is changing shape. Just kind of like a water, if it's in a tall, skinny container, it'll fill up the tall, skinny container. But if I move it into a Mickey Mouse shaped container, it's going to take the shape of Mickey Mouse. So as we move things around, gases do not keep the same shape. They change shape. They match the shape of the container. Now, the other thing that's true about a gas is when we move them from one place to another, they also can change size. So if you have that tank of helium and you want to fill up a bunch of balloons, you can do that. So let's maybe draw another Mickey Mouse balloon, all right? And then, oh my God, everybody is a fan of Mickey Mouse at this birthday party. So we're going to fill up a bunch of Mickey Mouse balloons, right? So when you take that helium out, it might be sort of in a one small container, but if you open up the valve, it's kind of compressed in that container. It can go out and it can fill up a bunch of Mickey Mouse balloons, and their size is way bigger than the container that they have at the store. So as you open up the valve, the gas in this case, it expands and it can actually fill up a bigger volume than that container in the store. So do gases keep the same volume? No, they do not keep the same volume. They change volume. You can actually squeeze a gas and make it smaller. Or in this case, what I did, you would be doing is you would be letting out pressure, and if the pressure is reduced, it can expand. The gases can expand. So let me show you that like with one other slide here. All right. So this kind of shows you the same idea. A solid, when you put in something, it keeps the same shape and size. When you have a liquid, it keeps the same size, but it'll take the shape of the container. So it'll spread out to fill up the container. But if you have a gas, not only does it change shape like a liquid does, it also changes size. It'll fill up the entire container. All right, so with that, that's a little bit about the difference between a solid, liquid, and gas. So that's the end of part A. We'll move on to part B and C in the next videos. Totally different topics. All right.